Hey everybody, this video is on the initial startup of the AR3 robot. So I've got my robot built, it is in the rest position, and I've got my control enclosure built. So the first thing that I want to do is refer to the manual on Chapter 7, the startup procedure. So I will look at this first diagram, and so I've connected my Ethernet cables. The yellow wire indicates the Ethernet cable that carries the limit switch connections from the base of the robot to the enclosure. The red arrow indicates the wire that carries the encoder signals for encoders for axis 1 through 3, and the blue is the encoder signals for axis 4 through 6. So I have those connected. Next is the motor power cables. I've connected 1 through 6 to the connectors on the control enclosure through 1 through 6. And then the 7th axis is optional. That's a 7th axis travel track that you can build, and there's a manual on the website that you can look that up. And then I've got the 2-pin wire going from the 5-volt DC connector on the enclosure to the base of the robot, and that carries the 5 volts that powers the encoders and the limit switches. And then finally, the last thing, after all those are connected, then we can hook up the USB cables. We're going to use 2 USB cables, one for the Teensy 3.5 and one for the Arduino Mega 2560, and I'll go over some details on those two boards here in a couple of minutes. So the first thing I want to do is get the software. So if I come here to the downloads and manuals page, at the very top of the page we have all the downloads for the AR3 robot, and we can download the control software either in the source code version or the EXE version. If you download the source code and you want to use that, you will need to install Python 3.7.4 is the current release right now, and then you would need to install the PySerial module, inputs module, and NumPy. And after those are installed, you could run directly from the source code. But in this case, for this video, we are just going to use the exe file. So I would download this zip file, and so I've done that, and I have it unzipped here on my desktop. So if I open that up and find the exe file, that's the application file, double click on that, make sure that opens, so the software opens up. You can say it says unable to establish communications, and we look at the log file, and here it says unable to establish communications with the Mega and the Teensy, and that's of course to be expected because they're not set up yet. So I will close this for now. So then that brings us to loading the software onto the Arduino Mega and the Teensy 3.5. So the Teensy 3.5 is a small control board that we've used, and that control board is used strictly for the robot, for the 6 motors, 6 encoders, and the limit switches for the robot itself. So the Teensy 3.5 is just used for the robot control, and the reason we've upgraded from using the Arduino Mega to control the robot is that the Teensy 3.5 has a clock speed of 120 megahertz and has a RAM of 192 kilobytes. It's a much faster board. It's capable of running all of the encoders. This board does operate at 3.3 volts, but all of the pins are 5-volt tolerant, meaning I can send 5 volts out to all the encoders and then receive the encoder signal back at 5 volts, and it will work with the Teensy 3.5. Now the Arduino Mega has a clock speed of only 16 megahertz and RAM of only 8 kilobytes, so it's much slower, and so that's what was used as the only control board on the AR2 robot. But I've kept the Arduino Mega for the AR3 because it's a great little board for controlling inputs and outputs and controlling servos. So I've kind of kept this board in the architecture as a kind of an I/O board for controlling things. For example, I use it to control my gripper, to control the solenoid valve. So to load the software on both of the boards that we're using, both the Teensy and the 3.5, we're going to need to install the Arduino software, the Arduino IDE. And for the the Teensy 3.5, it requires the use of a kind of a downloader program to interact with the Arduino software. The Teensy is a board that was developed and created by PJRC. So I'm here at their website, at the PJRC website for the Teensy Duino version 1.4. So the Teensy Duino is a software loader that allows the Teensy to interact with and become part of the Arduino software, and you can load sketches to the Arduino. The control software for the Teensy or the Arduino, they're called sketches, but it's just a program that we're going to load to the board. It's called a sketch. So here on the website for the Teensy Arduino, it goes through all of the steps to install it. And it says here, first you must download the Arduino software, and also you need to make sure that the Teensy Arduino is supportive, that it supports the current version of whatever Arduino IDE you're going to install. So you can see here that it's at this current point in time, it says 1.8.10 is in beta testing, so we're going to use the previous one. So right here I can see that version 1.8.9 was the last supported version. So I'm going to go here to the Arduino website, and then I'm going to look on the previous releases. I'm going to come here to the previous release web page, and I can find right here 1.8.9 is the previous release, so I will download that. Okay, so that is downloaded, so we will install that. Okay, so the Arduino software installation has completed. So the next thing we're going to do is install the Teensy Arduino software. So I'll come back to the PJRC website and come right here to the Windows installer. So I'm going to click and download that file. So that's downloaded, and we will open the Teensy Arduino exe, and we'll go through the install process here. Okay, so that's all finished up, so we'll click done. So I'm going to go back to my desktop. I can see now that the Arduino software has installed on my computer. And from the website here, we have a couple more downloads. We have the Teensy 3.5 sketch and the Arduino Mega 2560 sketch. So I've downloaded both of those to my desktop. So right here I've got the ARCS Teensy sketch. I'll open this up, and inside that folder is a Teensy sketch INO file. So I'm gonna open that up, and the Arduino software will open up the sketch, and we can scroll through here and see all the code that we're going to load to the Teensy 3.5. So when we go here to Tools, under Board, I'm going to choose the 3.5 board here. And then next, I'm going to go to Tools and go to Port, and I'm going to find the COM port in which my Teensy 3.5 is plugged into. So now I've set it as a Teensy 3.5. I've opened up that port, and now I should be able to click the Upload button. You can see down here it says Compiling Sketch, so that'll just take a minute. So you can see the Teensy Arduino loader automatically opens up, and loads the sketch to the board, and it says right down here, done uploading. Now it says here, press button on Teensy to manually enter program. I haven't had to mess with any of the, using the button. This seems to work just as you saw there to load the sketch to the board. So now that that's done, I will close the Teensy Arduino software, and I will close this sketch. And now the next thing I want to do is I want to do the same process, but I want to load the software to the Arduino Mega board. So we already did the Teensy sketch. I'm going to open the Arduino Sketch for the ARCS software and open up that sketch. Okay, so this is the sketch that's on the Arduino Mega, and again, this code here just handles all the inputs and outputs. So you have a number of inputs and outputs, and you can also control servos and a number of other things with this board. So again, we'll go to Tools, and then we need to select what board we're on, which is, let's see here, we can get it to stay on there. So right here, Arduino Mega 2560, I will select that. And then I'll go back to Tools again and go to Port. And we can see that the Arduino Mega is on port 4, so we'll select that. And then we will hit Upload. Okay, so it says done uploading. So I want to again make note of the ports that we're on. We're on ports 3 for the Teensy and port 4 for the Mega, and my instance here will likely be different than that. So we will close that, and then we will go back and open up the ARCS control software. Okay, so it again gives you an error. Go to the log screen. It says unable to establish communications. So on this screen, we're going to change the Teensy COM port to COM port 3 and hit set COM. And it says system ready. And if I go to the log, it says communication started with Teensy 3.5. So we're talking to that. So then we're going to do the same thing for the Arduino Mega. Come back here, and for the COM port on the Arduino Mega, we'll put in 4 and hit set COM. And it still says system ready. We'll go to the log, and it says communication started with a Mega 2560. So we have communication set up with both of our controllers. So now the next thing that we can do is test jogging the robot. So the first thing I want to do is, with the robot standing in the vertical position, this is the rest position. This is the position you're going to leave the robot in when it's not running. So when you have your controller powered off, the robot won't collapse on itself. The motors, when they're powered up, obviously are rigid and are going to hold the robot in any position, but when they're powered off, they're not holding force, so the robot could collapse on itself slowly. So leaving it in this vertical rest position is the ideal position to park the robot, and there is a program called rest which has a move here in the command window which will drive it to the rest position. But since the robot currently is not calibrated in any way, shape, or form right now, we can come to the calibration window, and there is a button here for calibrate at rest position. So this is, I'll click on that, and it will say calibrated to rest position. And that's the first thing I want to do. And so now the robot is kind of roughly calibrated, and it's close, it's somewhat close in the vertical position. So now we can at least jog the robot around safely. So that's the first thing I want to do, is test each motor that it will jog in a direction. So I'm going to turn my speed down to maybe, let's say, 10%. And I'm just going to go through and jog each axis and make sure each axis turns appropriately. So if I click the negative direction there, you can see the robot's moving in the negative direction, and we'll try the positive direction. And it goes in the positive direction. And same thing with, with joint 2. We'll try in the positive direction, and the robot, you can see joint 2 is working. So we'll just go through and check each joint just like that and make sure that each joint jogs in a direction. So if you click these buttons and the robot does not jog in any direction at all, then I would obviously go through and check all your wiring in the manual here. Up in the wiring section here, for wiring the drivers, I would go through and of course check that all of your AB wires are connected properly. And generally when somebody doesn't get any activity at all, it's because this pulse wire, the blue ones you see in blue here, that the controller isn't getting a pulse signal or it's landed on the wrong pin. So if it's not jogging in any direction, check that. Now if you click jogging in the negative direction and the positive direction, and both buttons make the robot go the same way, then the robot is generally not getting this direction input, the green wire. So check all your connections on the green wire. If the robot is not, is just going the same direction no matter which button you press. And then another thing, if the motor is making kind of a growling noise but not moving smoothly, like it's stuttering and growling and making some funny noises, that is typically when these A-B wires are not wired correctly. If you have one of them crossed over, an A to a B or B to an A, the motors will tend to run very, very oddly. So those are a couple of things to check there as far as that goes. So after I've tested each motor and I've verified that every motor moves as intended, so we'll just check each one here. And I hit J3 minus and it says J3 axis limit. That's because J3 is already standing up vertical and it doesn't go back any further, so we'll try the positive direction. So that's working well. We'll check joint 4, joint 5, and joint 6. So we've tested each joint, and so now we want to calibrate the robot. It's one thing to be cautious of. I wouldn't hit auto calibrate right away, right out of the gate. I would use these individual joints and calibrate one joint at a time. And before you allow the robot to make a full rotation, I would depress the limit switch with your hand quickly to give you time to stop the robot if it doesn't respond. So a couple things on that. On the limit switches, it's very important that every single limit switch has a good positive connection to 5 volts. That's the red terminal on each switch here, and you can see here it says the red wire is to be connected to the 5 volts on the GX16-2 socket connector, and the black wire is connected to the negative, which is the negative 5 volts on the GX16 socket connector. So every single limit switch, all 6 of them, have to have a good connection to positive and negative 5 volts. If any one of them has a bad connection, then none of them will work. And then of course the signal wire coming back needs to be on the correct wire to the what I've specified as the yellow Ethernet cable to these pins shown here on the Teensy 3.5. So if you did have a problem with a switch not being wired correctly, and you were to if you were to just come into the software and press J1 calibrate, and there was a problem, it could overdrive across that switch and bend your switch. So what I suggest doing is hitting the J1 calibrate button, but then be ready to press the button with your finger real quick. That gives you time. If it does not stop when you press it with your finger, you could hit the E-stop button on your controller and stop the robot before it damages your limit switch. So I'll just demonstrate that here. I'm going to hit the calibrate button, and then I'm going to reach over and press the switch, and the robot stops, and it says calibration successful. Obviously it was calibrated incorrectly, but I was able to press the switch, stop the robot, and verify that my switch is working. So I would do that with all 6 of them except for axis 5. Axis 5 you can't really get to the switch. It's up here inside the it's up here inside the arm up here. So, but that one I wouldn't worry about too much. It's just the carrier is going to come up with the inside of the housing, and there's really nothing that can be damaged there. So joint 5 is not really a concern, but I would go through and test that and calibrate each one of these separately. And then once you've done that and tested each one, then you can hit auto calibrate. And what the auto calibrate will do is it will run the entire robot to its full negative limit. It'll drive off of the switches and then slowly in a controlled speed back onto them. And then it will come back up to the rest position, and then it will calibrate axis 6 last. So axis 6 has some potential that with the cable, the way the cable bends at the position it is, it can get a false calibration when the cable hits the limit switch. So I've programmed it to calibrate axis 6 last. So at this point, we've started up our robot. We've got everything working. We've tested our limit switches. We've tested our calibration. We're fully calibrated, and now we're ready to use the robot. A couple other things real quick. The encoders. If you have any issue with the encoders, if there's a wiring issue, you'll keep getting an error, and there'll be a message in the log that tells you that it's detected a collision for that axis. So if you run into any issues like that, you would of course need to check all of your encoder wiring very carefully. And the other thing you could do is on the calibration tab, I have buttons here that you can check to disable the encoder so that you could do testing. So if you wanted to disable an encoder for axis 1, for example, you could disable the encoder and do testing with it. But just to demonstrate how the encoders work or how it would detect it, I'm going to I'm going to kill the power to my controller here. I've hit the E-stop button. That shuts off the 24 volts to each of the drivers, and then I can manually, for example, I can just manually rotate axis 4 and then turn my power back on. And so now when I go to execute this rest position, it's going to tell me it's not going to execute the position the first time. It's just going to give me an error that says J4 collision or out of calibration. It'll add it to the log screen, J4 collision or out of calibration. And then if I go ahead and execute the position again, it will correct itself and go back to the correct position based on what the encoder told the control software happened. So that kind of simulates what would happen if you crashed the robot or if something moved and it shouldn't have. The encoders will correct it, and that's that error right there, that collision error is the error you'll get if you're having issues with your encoders. So I think that's it for this video. That covers the basic startup procedure, loading all the software and getting the robot up and running. All of the videos on YouTube for the AR2 robot for programming are all applicable to the AR3, so you could watch all those videos and they will go through everything relative to the programming. I will also be making more videos and adding more content for programming of the AR3, but until those videos are ready, the AR2 videos are certainly just fine. So that's all I have for this video, and thank you for watching.